Okay, lesson 1.6 is on parent functions and their graphs. We need to learn how to recognize graphs of parent functions. So we're going to just start off by looking at various functions. When we're looking at the first function as a constant function, that's a form of a linear parent function. And this would be y is equal to, instead of y, let me call it f of x. F of x is equal to some constant. So that's just a number, and what the graph of a constant function is going to look like it's just going to be some value that's a constant value. This could be c is equal to, let's say, 2.7 or whatever. So it's just a constant horizontal line. The next one we're going to look at is linear. This is f of x is equal to x. This is the parent function of a linear. It could be in several forms. We could have, say, f of x is equal to 2x plus 3. This is still a linear because the parent function is f of x is equal to x. That's the parent function. Even though it looks like this, it still has the parent function, f of x equal to x. So if we were going to graph that, f of x equal to x, let's start off with a coordinate system. And graphing it would just be going right through the origin, and the intercept point is 0, 0. And we wanted to list the domain. Domain is all real numbers. If we wanted to list the range, is also all real numbers. Now, if we wanted to graph something like the 2x plus 3, it's still going to be a straight line. And again, the parent function is just f of x equals x. Okay, let's look at the square function. The parent is f of x equals x squared. And these can take various forms, like f of x is equal to 2x squared minus x plus 1. This is still has a parent function of x squared, even though it's 2x squared minus x plus 1. So you're looking at, because it's a square function, mainly because it has a square term here. And again, the parent function, the simplest x squared function, is just f of x equals x squared. And so if we wanted to graph that, we know this is going to be a parabola. So graphing the parabola, it's going to take this shape. Again, the intercept of x squared of the parent function is 0, 0. If we are going to say the domain of x squared is going to be all real numbers. The range, what is the range allowed to be? Well, it doesn't get any less than 0 in this case, so the range is going to be it'd be a bracket, because it can be equal to 0. So we're going to make a bracket 0, comma, infinity. One more thing we know about the square function: it is symmetric with respect to the y-axis. What that means is you can rotate it on the y-axis. If you rotate it 180 degrees, the function will look just the same. So this is symmetric with respect to the y-axis. It's also an even function. And even and symmetric with the y-axis mean the same thing. Now, that's only for the parent. This particular equation, 2x squared minus x plus 1, would not be symmetric with respect to the y-axis, and it wouldn't be an even function. It would be neither, not even or not odd. Okay, now for the cubic function. The parent is f of x is equal to x cubed. And again, this can take many forms, just like the square function. It could be 2x cubed minus x squared plus 7 or something like that. all of that is going, the parent for those are going to be x cubed. Well, the x cubed functions, since x can be positive or negative, the function is going to have a graph that's going to look like this, and it's going to go through 0, 0 is the intercept. And because you can have positive and negative numbers, the domain is going to be all real numbers, and so is the range, all real numbers. And this happens to be an odd function. And that's because if you take the function and rotate it about the axis, about the origin rather, if you rotate it 180 degrees about the origin, you end up with the same looking graph. And so this means this is an odd function. And odd functions, we say, are symmetric with respect to the origin. Okay, the next function, square root function, f of x is equal to the square root of x. And we know that x cannot be less than 0 because we're still talking real numbers, not imaginary numbers. And so it's going to start, if we were to graph this, okay, you probably heard my phone ringing there, so I had to stop for a second. So back to the square root function, f of x equals square root of x. And we want to graph this. It's going to look like this shape here. Again, the intercept, 0, 0. And if we wanted to look at the domain for this is going to be greater than 0. So we would write it bracket 0, comma, infinity. And the range, same thing. The range is going to be greater than 0. So it's going to have the same 0, comma, infinity. So this is the square root function. And again, you have the origin or the intercept at 0, 0. Okay, so the next function is the reciprocal. The parent reciprocal function looks f of x is equal to 1 over x. And in this case, you have to put, well, we'll look at the domains, but on the parent function, x can't be 0. It can be negative, it can be positive. And so what this function is going to look like when we graph it, so let's just do a quick XY table. So when x is negative, well, let's just start off when x is 1, y is equal to 1 over 1, which is 1. When x is 2, y is equal to 1 over 2, so 1/2. And let's say when it's 10, y is equal to 1 over 10, which is 0.1. And these can be plus or minus, all of them. And so at the end, the y's would be plus or minus also. So if we were to graph these graphs look, well, they're called hyperbolas. So it goes like this, like that. Then on the other side, kind of like that. Let me clean this up a little bit. Now, you'll notice that the values on this hyperbola, we don't have any intercept points because x cannot be 0. And so at the x equals 0, which is the y-axis, both of these become asymptotic to the axis and they don't cross the axis. Likewise, on y equals 0, this can never be, f of x can never be 0. And so they approach the y equals 0 on both sides of the coordinate. And so this is called a hyperbola. The graph is called a hyperbola. And that's for the reciprocal. And again, you could have a 1 over x plus 3 or something like that. It would still have a parent function, 1 over x. Okay, the next functions are called step functions. They're not all that useful in precalculus. They are when we get to calculus, but here's what a step function looks like. Let me draw a coordinate frame. And so step function is going to look something like this. Let's see. So it'll be a dot here, and it'll go to a circle. Then another dot above it, and a circle, and a dot, a circle, so on and so forth. So what this means is if x is between 0 and 1, you have a constant value y equals 1. So right here, let's say at this point right here, x equals, let's say 3/4. Y is going to equal to 1. Or if we could have x equals 0 at that point, right here where the dot is, x equals 0, and y is still equal to 1. Y doesn't become equal to 2 until the value of x steps up to 2. X could be 1.99999, a little close to 2, but the value of y is still going to be 1. Doesn't change until x actually jumps up to the value 2, and then y becomes 2. And it'll stay 2 until x becomes 3, and then y is 3. So that's called a step function. Again, not all that useful in precalculus, but we'll see it every once in a while when we're doing some lessons. And I forgot to mention, the function actually looks like f of x is equal to x, but there's like a bracket and then another number. It's almost like a absolute value sign, but it's got two vertical lines on both sides of the x. So that indicates a step function. Okay, the next function, absolute value function, that's f of x is equal to absolute value of x. So that means if x is positive, you're going to have a positive value. If x is negative, you're going to have a positive value. And so what these graphs look like, well, the parent function is going to look like this and this. So in both cases, the y value is always going to be positive. So what's the domain? Domain is all real numbers. And the range is 0 to infinity. You could also write it, the range, as y is greater than or equal to 0. Both of them mean the same thing. Okay, the piecewise function doesn't really have a parent. Piecewise functions are made up of two or more other functions to combine them into one particular function. So, for example, a piecewise function, they can get really weird looking, and we're going to do some examples of a piecewise function, but you might have a piecewise function that does something like this, starts out, and let me do it in red. Okay, say like we start out here with a dot, and then we just come up here, we put a circle here, because it's going to start right here again, and like that. So let's say it starts here again and does something like that. This would be a dot, and this would be another circle, and then we'd have a dot here, and it could be straight like that. Anyway, these can look pretty weird, but they're functions because remember the definition of a function. You can draw a vertical line and it will only cross the graph one time, or not even one time. And because we have the circles and the dots, like right here, we draw a line through that point, and since it goes through the circle, that doesn't mean that's included in the graph. It'll go through the dot, and that's fine. And so these are still piecewise functions, and we'll do an example of piecewise functions a little bit later. Okay, example 1. I'm going to write a linear function. Remember, this is going to take the form f of x equals x. That's the parent. And so given we have f of -2 is 6, well, that means when x is -2, y is 6. So we can put our dot there. And the second point, f of 4 is equal to -9. So 4, -9, right here. So let's go ahead and draw a line. Okay, so now, first thing we want to do, we need to find the slope. Well, we know the slope is equal to delta y over delta x, which is going to be -9 minus 6 over 4 minus 2. Or minus a minus 2, so 4 plus 2. So here we have -15 over 6. And so that's our slope. Now, we're going to use the point slope formula. It's always a good idea, write the formula down first and then substitute the values. So y is equal to m times x minus x1 plus y1. And you can use either point as x1, y1. I think I mentioned I usually use the ones on the left-hand side as my as the point 1, and the right-hand side is point 2. So let's just fill it in. M is -15 6 times x minus, well, x1 is a -2, so it's minus 2, plus 2, plus y1, which is 6. And then we clean that up. So it's -15x over 6 minus 30 over 6. And we have to change the 6 into 6. So again, this would be 30 over 6. Oops, I meant 36 over 6. So that's going to be minus 15 6 x plus 6 over 6, which is 1. So there's our equation. Put a box around the answer, and we're done. Okay, example 2, graph a piecewise function. So let's look at our function. F of x is equal to -1/2 x minus 6, and that's when x is less than or equal to -4. And second part, x plus 5, and that's when x is greater than a -4. So we know that both of these are going to be linear, and so we only need 2 points for each equation. So let's look at the top equation, and let's do an xy table for the top equation. And we know that x has to be less than or equal to -4, so let's start off with x being -4. Put that into our equation, so we have a -1/2 times -4, so that's 2. 2 minus 6 is -4. Now let's pick another point. Should pick an even point to make the numbers work out a little better. So let's say when x is -6. -6 times -1/2 is 3. 3 minus 6 is a -3. So that's all we need to plot the first equation. Let's go ahead and do that. So we have -4, -4. And this is going to be a dot because it's a greater than or equal to. And then our other point, -6, -3. -6, Negative 3 is right here. And so we can go ahead and plot this now. It's just going to go like that, and it's going to continue on. Don't have to draw the arrow, but sometimes it's handy. Okay, let's do the second equation, x plus 5. Well, x is greater than a negative 4, so let's do another xy table. What we want to do is actually plot it as if it was equal to a negative 4, but we're going to put a circle there instead of a dot. So when x is negative 4, y, negative 4 plus 5 is 1. So the value is 1. So when x is a negative 4, the value of 1, and that's going to be a circle. Then let's plot another one. Well, let's say when x is 0, y is going to be 5. So let's plot that. 0, 5, 1, 2, 3, 4 is right here. Then we can draw our line. It's going to look something like that, and it's going to continue on. So this is a piecewise function, and notice we know it's a function because we can draw a vertical line anywhere, and it's only going to cross the graph one time. So if we draw a vertical line here, for example, covers it one time. We can even draw a graph here, or a line right here. You notice it goes through the dot here, which is fine. That's where it touches the graph one time. Technically, it doesn't touch this hole in the graph, so this means this is a function. So we're done with 1.6. I'll post the homework right after I post this lesson.